All right, so we've gone over how to determine the formula from an ionic formula's name. Now we want to figure out, well, if I have the formula, how do I name it? How do I basically go in the other direction? So if you've already read or studied up on molecular naming, this is going to be a little bit different than that. So we need to, when we look at a formula, we need to see how do we even know it's ionic? And I discussed this in another video, but typically it's a metal and a non-metal. So for example, K2S, the key that this is ionic is it's got K, which is a metal, and S, which is a non-metal. And just in case you're forgetting, on the periodic table, the metals are always to the left of the staircase that we usually see, and the non-metals are to the right. So you're usually looking for a metal and a non-metal. That's the clue that it's ionic. So here I've got calcium and nitrogen, metal and non-metal. Here I've got Mg as a metal. Now, NO3 is not a non-metal per se. It's a group of things, but it's a polyatomic ion. It's one of these NO3. It's one of these groups. So that's a dead giveaway that it's ionic because it has a polyatomic ion in it. So this next one, there are no metals at all in NH4OH. But this is an ionic formula because it contains NH4, which is a polyatomic ion. It also contains OH, which is a polyatomic ion. So it's not always a metal and non-metal, but be on the lookout for that. So once you've determined that, the key is ionic formulas have two names. They have the name of the positive ion and the name of the negative ion. So one way to do this is to look at the formula and separate the two. And if there's only two atoms present, it's relatively easy to separate. So K2S, you've got the K and you've got the S. So the positive is on the left, the negative is on the right, K2S. Here I'm separating between Ca3 and N2. Now, for the polyatomic ions, I separate before the polyatomic ion. Mg is the metal, NO3 is the non-metal substitute. NH4OH, well, NH4 represented the positive and OH represented the negative. That's where I'm dividing it. So usually it's just a matter of dividing between the two, but when there's parentheses or a polyatomic ion involved, it might be slightly trickier. But that's the first step. And then we just name each side. So for example, K2S, what's K called? K is called potassium. So I just say, okay, this is potassium. And then what's sulfur? Well, we don't say potassium sulfur. Remember, we always, if it's a regular type of atom, we change the ending to "ide." So this is potassium sulfide, not potassium sulfur. Here, then you may say, what about this two potassiums? Why don't I say dipotassium or potassium 2 or something? It's not necessary. One way to test to see if you've done this right is cover up the original formula and say, can I get the formula from this name? And if you remember back to what we did before, potassium is +1, sulfur is -2. I can get the original formula again. I don't know why the 2 is not appearing. There we go. I can get the original formula back. I don't need to say dipotassium or anything like that because the charges will tell me the actual formula. So don't ever put prefixes in ionic formulas. So next, Ca3N2. What is Ca? Ca is calcium. N is nitrogen, but we don't say calcium nitrogen, we say calcium nitride. I've seen people write nitrogide, just learning what the common endings are. Like you'll start to see what sounds right, but it's nitride. MgNO3 well, Mg is magnesium. And NO3 is one of those special groups, so we look at the group, and NO3 is nitrate. So this is magnesium nitrate, not nitride. So there is a difference. If it ends in "ide," it's just one type of atom. Usually if it ends in "ate," it's a group of them. NH4 from our chart was called ammonium, so it's ammonium. OH is hydroxide. This is one of the exceptions. As far as ides, it is a group. All right, FeO. When I say, okay, iron, Fe is iron. And O is oxygen oxide. But there's a problem here, and I'm just going to go ahead to the next one so you can see. Oh, Fe, iron. O, oxygen oxide. If you notice, iron oxide, this is the same name for two different chemicals. So, again, the test. If I give you iron oxide, can you tell me the formula? And again, if I look back where iron is on the periodic table, iron's here. I have no idea what its charge is based on its location. So that means that when I write the formula, I can't just say iron oxide. I have to figure out what the charge is. So I have to kind of work backwards. So I say FeO. Okay, there's one Fe and there's one O. Now, we know oxygen's charge is -2 from the periodic table. So what does Fe's have to be to balance that? It's got to be +2. Because this is all there is, +2 and -2. So this one must be iron 2 oxide. What about Fe2O3? I'll draw it out. 2 irons, 3 oxygens. Okay, O is -2. So if there are 3 of them, this adds up to -6, which means this side has to be +6. So these 2 irons are splitting a +6 charge. They each must be +3. So I actually have to go backwards and figure out the charges in the cases of atoms that can form more than one charge. So basically, if you ever see an atom in an ionic formula that is in this middle part of the periodic table, typically, you need to figure out the charge. One exception is silver is always +1, and zinc is always +2. But there are, for the most part, that's what you're going to have to do. So figure it out, and you can draw it out again if you like. I think that does help, sketching this out and seeing how they balance. But whatever the case, one way to test is go from the formula, see if you can get back the original answer. All right, PbSO4 So Pb, I just got to make sure that that charge is correct. So if I have 1 Pb and 2 SO4s, SO4s are both -2. So yes, Pb is +4. So I'm going to call this lead 4 sulfate. Lead sulfate isn't really sufficient. I think I talked about this before. Even though lead is in this area of the table, it's one of those ones that can form multiple charges. A lot of the ones with the Latin symbols can form multiple charges, like tin, lead, iron, these ones that have sort of strange symbols based on what you know them as their names. So just be aware of that. So for ionic formulas, it really, for the most part, it's just a matter of writing the first and the second. No prefixes. The only time it gets tricky is when you're dealing with these ones that can form multiple charges. Then you have to do a little bit of detective work, figure out the charge, but then you just throw it on as a Roman numeral. So just be aware of those, but other than that, you should be able to kind of fly through these ones. So until next time, I am Derek Genova. Have a delightful day.